Hello viewers, thank you for visiting this channel and for opening this video. This channel is dedicated to solving national and international mathematics examinations with special focus on Ethiopian secondary school leaving certificate examination and Ethiopian university exit exams. In this video, which is my sixth teaching video, I am going to solve 8 problems from the 2024 Ethiopian Secondary School Leaving Certificate Examination on Mathematics from booklet code 096. The problems which we solve, or which I solve in this video, include the following ones. Question number 1, 2, 3, 4, 5, 6, 7, and 8. Before I start solving these problems, as usual, I kindly request you to subscribe this channel and like this video. Let us start with the first of these problems. Problem number 1 from booklet code 096 of the 2024 Ethiopian Secondary School Leaving Certificate Examination reads like this. Problem number 1 says, in the set of natural numbers, which one of the following defines a composite number? Before we solve this problem, let us see or recall the definition of composite number. And before we define composite number, we have to recall about the meaning of factor, multiple, divisibility, and so on. If we have the product of two numbers, say a times b is equal to c, where a, b, and c are natural numbers, c is called the product of a and b, or separately c is called a multiple of a. We can also say c is a multiple of b, but we do not say c is a product of b. We say c is a product of a and b. C is a multiple of a, c is a multiple of b. And similarly, we say a is a factor of c, b is a factor of c, a and b are factors. Or we can say a is a divisor of c, b is a divisor of c. For example, we know that 5 times 4 is 20. So 20 is a product of 5 and 4. 20 is a multiple of 4. 20 is a multiple of 5. 5 is a factor or divisor of 20. 4 is also a factor or divisor of 20. Natural numbers can be divided into three different categories, depending on the kind of factors they have. These are those which, okay, let us read this definition. This definition is given in school mathematics, grade 9 or 10, you can check it. I took it from school mathematics textbook. A natural number that has exactly two distinct factors, namely 1 and itself, is called a prime number. And a natural number that has more than 2 factors, more than 2 means 3 or more, is called a composite number. We can divide natural numbers into 3 subcategories based on this definition. Those which have 2 factors are called prime numbers. Those natural numbers having 3 or more number of factors are called composite. And one is special. It's not prime, it's not composite, because it has only 1 factor. So let us answer the problem now. In the set of natural numbers, which one of the following defines a composite number? A number that has only 2 distinct? No. A number which has only 2 distinct factors is prime. A number that is divisible by numbers from 2 to 9? No, the definition does not say this. See, a number that has 2 or more different factors, 2 is not correct. A number that has 3 or more different factors, divisors and factors are the same. A number that has 3 or more different divisors, or you can also say factors. So the correct answer is D. Let us move to the next problem. Which one of the following is true about rationalizing the denominator of a certain number? Again, before we read the choices, let us see what rationalizing the denominator of a number means. By this we mean reducing the given number. Well, usually this definition applies to fractions. To rationalize the denominator of a certain fraction means to reduce that fraction to an equal fraction in such a way that the denominator of the new fraction is not irrational and the denominator of the previous fraction is irrational. Rationalize the denominator of a fraction means reduce the fraction to rationalize the denominator means to reduce a fraction with a rational denominator to another fraction, an equal fraction with rational denominator, converting a rational denominator to rational denominator without affecting the number. For example, if we take 4 over root 2, if we multiply this by root over root 2, which is 1, we get 4 into root over 2, which means 2 into root 2. So the denominator becomes rational when we multiply the number on a by root 2 over root 2. And that's what rationalizing the denominator of a number means. So let us see read the choices. A, only the denominators can be multiplied by a rational number. No. Since the magnitude of the number should not be changed when you rationalize a number, both denominator numerator must be multiplied by the same number. So A is not correct. B, only numerators can be rationalized when there is a radical. No. C, it is a matter of changing the denominator into a rational number. Yes, that's why we say rationalizing denominator, changing denominator to rational without affecting the number. So the correct answer is C. No need of checking D. Is it a technical multiplying a given number by a rational expression? No. We multiply a given number by 1. When we rationalize denominator, we multiply that number by 1. Okay, number 3. When dividing 142 by 13 and express the result by applying the division algorithm, we get what? So what's the division algorithm? First, we have to recall this theorem, which is taken from school mathematics textbook. Euclid's Euclidean division lemma or algorithm says, given a non-negative integer a and a positive integer b, a and b, where a is non-negative and b is positive, there exists unique non-negative integers q and r. Satisfying this equation, we can always write a and b as a is equal to b times q plus r. We can find two more numbers, q and r, in such a way that the last term, r, is between 0 and b. 0 is less than or equal to r less than b. And this r is called remainder. The two given numbers a and b. A is called dividend, b is called divisor, and q is called quotient. So for example, in the current problem we are given 142. When we divide 142 by 13, what is the quotient? What is the remainder? That's the question. So a is, if we take b, it's not correct, because even if 142 is the same as 11 times 13 minus 1, but we cannot take negative 1 as remainder. Remainder should be between 0 and the divisor. The divisor in this case is 13. And negative 1 is not between 0 and 13. See, 142 is it's not 11 times 13 plus 1, because 11 times 13 plus 1 is 144. You can check it. 13 plus 31, 4, 3 plus 1, 1, 4, 4. And the last choice, D, is also not correct, because 142 is, yes, it is 10 times 14 plus 2, but when we divide 142 by 13 should appear as divisor here, as it is the divisor of the given division. It should have been included here. So D is not correct. The only correct answer is A, and so the answer is A. Let us move to the next. The solution set of this system of equations is what? When we solve any system of linear equations, be whether it has 2 variables or 3 variables or whatever, the first step is, let us see the steps which we should follow. Step 1, put the equation in standard form. That means write all constants, or take all constants to right hand side, on the right hand side, and all variables or unknowns to left hand side. So for example, for the current problem, in the second equation, x is on right hand side, and we have to take 6x to left hand side. Moreover, variables should be aligned in one line. To x minus y is equal to 5 in the first equation, negative 6x plus 3y is equal to negative 15 in the second equation. So we changed the system to standard form. After that, if we want to use matrix theory, detach coefficients, write a matrix representing the system. So the coefficients of x are 2 and negative 6, the coefficients of y are negative 1 and 3, the constant terms are 5 and negative 15, so we get this matrix. And by using elementary row operations, you can convert this matrix to the last one, 1, 0, negative 1 over 2, 0, 5 over 2, 0. And an equivalent system for the last matrix is, since 1 corresponds to x, we get x minus 1 over 2y is equal to 5 over 2. X minus 1 over 2y is equal to 5 over 2. If we let x is equal to t, if in place of x we put t, then y becomes, even from the first equation we can see that y becomes 5 minus 2t minus 5. So the correct answer is t comma for xt for y 2t minus 5. That means C. This system of equations have infinite number of solutions because t can be any real number. We can put, for example, in place of t 0, if we put t means x, in place of x if we put 0, y becomes in that case negative 5. If t is 0, y becomes negative 5. Negative of negative 5 is 5, correct. If we put in place of x 0, that means t 0, y becomes negative 5, 3 times negative 5, negative 15 plus 15, 0 is equal to 0 is correct. So for example, 0, negative 5 is a solution, and there are also other solutions. By taking different values for t, we can calculate values of y, and we get many solutions for this. It has infinitely many solutions. The next problem, problem number 5, is the product of the roots of the equation 4x squared minus 2kx plus k minus 1 is equal to 0 is negative 3 over 2. Which one of the following is the sum of the roots of the equation? In order to solve this problem, we have to recall or remember the formula for the product of roots of a quadratic equation and for sum of roots of quadratic equation. There are 9 formulas about product and sum of roots for quadratic functions. We are given the quadratic function 4x squared minus 2kx plus k minus 1 is equal to 0. The given quadratic equation is this from the problem. 4x squared minus 2kx plus k minus 1 is equal to 0. Product of the roots. The roots are not given, but product of the roots is given to be negative 3 over 2. You can check it is negative 3 over 2. And we are asked to find the sum of the roots. And the formula is sum of the roots S is given by negative B over A, and the product of the roots is given by C over A. Since C product is given, C over A becomes negative 3 over 2. But A, B, C are coefficients of the quadratic equation. A corresponds to 4, A is 4, B is negative 2k, C is k minus 1. So if we put in place of A 4, we can get C, and the value of C is also given k minus 1. If we replace C by k minus 1 and A by 4, we get the value of k, which is negative 5. And from the formula for sum of roots of quadratic equations, S is negative B over A, but A is given to be 4, so we have negative B over 4, and B is negative 2k, so we have negative of negative 2k over 4, which means k over 2. But k is negative 5, so we get negative 5 over 2, so the answer is the sum becomes negative 5 over 2, which means B. The next problem number 6. Which of the following can better be regarded as a universal set to apply to the set of operations on the sets, to apply to set operations on the set A is equal to and B is equal to. Two sets are given, set A and set B. If we want to apply set operations to these two sets, what should be the appropriate universal set? A universal set is a set that contains all elements that we need for a particular discussion. So in this specific discussion, the numbers given are, in A we have negative integer, positive integer, that means they are integers. In B we have 0, which is also integer, 3, which is also integer, 10 over 3, which is fraction, 15, which is integer. So in A and B, at most the numbers we have are rationals. There is no rational number in both sets. So an appropriate universal set for this discussion is the set of natural numbers. The set of rational numbers. The set of natural numbers cannot be universal set because negative numbers are included in this discussion. The set of integer numbers cannot be universal set because fractions are included. The set of rational numbers cannot be universal set because no rational number is given here. So the correct answer is D. The set of rational numbers is appropriate to be used as universal set for this discussion. The answer is D. Next problem. Given sets A is equal to this set, negative 1, set containing 0, the set containing negative 1, 0, and set B, the set containing negative 1, and 0. Which of the following is the relative complement of A with respect to B? እዚህ ጋር ጥያቄው ከባድ ባይሆንም በተማሪዎች መጽሐፍ ላይ ይሄ ዲፋይንድ የሆነበት መንገድና ብዙ መጽሐፍት ላይ ዲፋይንድ የሆነበት መንገድ ተመሳሳይ አይደለም። የተማሪዎች መጽሐፍ ላይ ግሬድ 9 ላይ ያለው ዴፊኒሽን ሪሌቲቭ ኮምፕሊመንት ምልክት ስህተት ይመስለኛል። ምክንያቱም ይሄ እንዴት አድርጎ ነው ሪሌቲቭ ኮምፕሊመንት ኦፍ ኤ ዊዝ ሪስፔክት ቱ ቢ መጽሐፉ እንዴት አድርጎ ነው የሚያስቀምጠው? መጽሐፍ ላይ ያለውን ዴፊኒሽን ከማየታችን በፊት ዊኪፒዲያ ላይ relative complement of A with respect to B, complement of A ማለት የA መሙያ ነው። A ጎደለው ነገር አለ ማለት ነው። complement of A ከተባለ ከB ኤሌመንቶችን ወስደን A ውስጥ የሌሉትን የB ኤሌመንቶች መውሰድ አለብን። A ነው መሙላት የምንፈልገው። A ጎደለው ነገር አለ B ውስጥ ደግሞ ያለ ነገር ከሆነ the relative complement of A with respect to B ማለት A ውስጥ የሌሉትን የB ኤሌመንቶች መውሰድ ማለት ነው። A ለመሙላት ነው የተፈለገው። A ጎደለው ነገር አለ ግን ቢ ውስጥ ያለ ነገር አለ ከቢ እየወሰን ቢ ውስጥ ያሉትን ግን ኤ ውስጥ ያሉትን ኤሌመንቶች ነው መውሰድ ያለብን ቢ ዊዛውት ኤ የተማሪዎች መጽሐፍ ግን እንዴት አድርጎ ነው ይሄን ዲፋይን የሚያደርገው the relative complement of A with respect to B ማለት complement of A ሆኖ ሳለ ግን መጽሐፉ A without B ያደርገዋል A without B A without B the set of all x such that x is in A and x is not in B well A without B ማለት እንደዛ ነው የዚህ ምልክት ብቻ ለብቻው ከፈለግን ይሄ ምልክት ምን ማለት እንደሆነ ትክክል ነው ይሄ ግን እዚህ ጋር የተቀመጠው ኮንሴፕት the relative complement በጽሁፍ መልክ በቃላት መልክ የተሰጠው በዚህ ሲምቦል ሪፕሬዘንት ሊደረግ አይችልም the relative complement of A with respect to B ማለት A without B ሳይሆን B without A ነው መሆን ያለበት B without A B ውስጥ ያለ A ውስጥ ያለ A ነው መውላት የፈለግን complement of A ስለምን ስለዚህ መጽሐፉን definition ልክ አይደለም እንግዲህ እንዲህ አይነት ጥያቄ ፈተና ላይ ብሔራዊ ፈተና ላይ ቢወጣ ምን ሊደረግ እንደሚችል አይዶን ነው ተማሪዎች በጊዜ የሚመለከተውና አካል መጠየቅ ይገባቸዋል ማለት ነው ለፈተና እየተዘጋጁ ያሉ ተማሪዎች ስለዚህ ይህን ጥያቄ አሁን እንስራው given set A is equal to this and B is equal to this which of the following is the relative complement of A with respect to B complement of A ስለሆነ A ምንድነው የጎደለው ለምሳሌ B ውስጥ ያለ A ውስጥ ያለ ምንድነው ነው set containing negative 1 set containing negative 1 የA ኤሌመንት አይደለም ስለዚህ እሱ መውሰድ አለብን A ውስጥ የለም set containing negative 1 አለ ግን set containing negative 1 የለም እሱ ይወሰዳል negative 1 A ውስጥ አለ እሱን አንወስድም አልጎደለም 0 A ውስጥ የለም A ውስጥ ያለው set containing 0 እንጂ 0 አይደለም ስለዚህ 0 እና set containing negative 1 A ይሞላሉ በB ኤሌመንቶች A መሙላት ማለት ነው complement of A ማለት ስለዚህ መልሱ A ነው መሆን ያለበት according to the correct definition በተማሪዎች መጽሐፍ ላይ ባለው definition መሰረት ግን A አይመጣም okay last problem for this video is problem number 8 let A be the set containing negative 2 negative 1 0 1 B 1 5 and R set containing negative 1 5 okay see pair of elements and element ይታያል negative 1 5 አንድ element ነው 0 5 አንድ element 1 0 አንድ element R ውስጥ ሶስት ኤሌመንቶች አሉ what's asked which one of the following is true so we have to know to answer this question we have to recall about relation and other concepts related to relations such as domain range and so on okay let us recall the definition of okay relation is a set of ordered pairs domain of a relation means the set of all x where x y is in R domain of R means the set of all x where x y is in R range of R means the set of all y where x y is in R ሁለተኛ ኮኦርዲኔት ላይ ያሉትን ብቻ በመውሰድ ሬንጅ እንሰራለን የመጀመሪያው ኮኦርዲኔት ላይ ባሉት ኤሌመንቶች ብቻ ወይም የመጀመሪያው ኮኦርዲኔት ላይ ያሉ ኤሌመንቶችን ደግሞ በመውሰድ ያሉ ኦብጀክቶችን በመውሰድ ዶሜን እንሰራለን ስለዚህ ዶሜን እና ሬንጅ ካወቅ ሌላው ብዙም አይከብድም ይሄን ጥያቄ ለመመለስ ኦኬ ዶሜን ኦፍ R ማለት መጀመሪያ ላይ ያሉትን መውሰድ ነው negative 1 0 1 the set containing negative 1 0 1 no domain so A is not correct range of R means set containing second coordinates 5 እና 0 ብቻ ናቸው ስለዚህ ጋር ሌላ ነገር ይጨምርበታል 1 አይሆንም B ላይ ያለው C ላይ ያለው R is a relation from A to B a relation from A to B means a subset of A cross B but R is not a subset of A cross B ምክንያቱም A cross B ውስጥ 1 0 አለ no R ውስጥ አለ sorry R ውስጥ 1 0 አለ A cross B ውስጥ ግን 1 0 የለም ምክንያቱም 0 B ውስጥ ስለሌለ A cross B ስንል it is a set of all xy's where x is from A and y is from B ordered pairoችን ይይዛል A cross B የመጀመሪያው ኮኦርዲኔት የኦርደርድ ፔሩ የመጀመሪያው ኦብጀክት ከኤ ይመጣል፣ ሁለተኛው ኤሌመንት ከቢ ይመጣል። ስለዚህ 1 0 ኤ ክሮስ ቢ ውስጥ አናገኝም። 1 ኤ ውስጥ ቢኖርም አዎ አለ፣ ግን 0 ቢ ውስጥ ስለሌለ 1 0 ኤ ክሮስ ቢ ውስጥ የለም፣ ግን አር ውስጥ አለ። ስለዚህ አር የያዘው ኤሌመንት አለ፣ ኤ ክሮስ ቢ ውስጥ የለ፣ አር ውስጥ ያለ ኤሌመንት ስላለ አር የኤ ክሮስ ቢ ሳብሴት ስላልሆነ ስለዚህ አር is not a relation from A cross B. We need to say R is a relation from A into B. R should be a subset of A cross B. ስለዚህ ስላልሆነ ሲም መልስ አይሆንም፣ መልሱ ዲ ነው። አር 3 ኦርደር ፔሮችን ይዟል። አንድ ኦርደር ፔር እንደ አንድ ኤሌመንት ትቆጠራለች። ስለዚህ R is a relation of 3 elements, a set of 3 elements. Thank you for watching this video or for listening this video. Please subscribe the channel and like this video. Thank you for listening again.